What's going on, everybody? Welcome to our ninth tutorial of our linked list series. In this tutorial we are going to check if our linked list contains a cycle or not, and it will be pretty similar to our 8th video. If you didn't check it, you can. We wanted to try to find the middle node of it, and we used double pointers there. The first solution will be with double pointers. However, there is a kind of better solution. We will use both and solve with both, but it's like a trade-off. We are going to trade our memory for speed, actually. Let's try to write it first, but let me explain the problem now. So if you check the code here, I have created a linked list which holds the values of 1, 2, 3, 4, and 5. And we have 6 nodes, but our last node is actually equals to the second node. But please remember this: if they are asking you to check if there's a cycle or not, that doesn't mean duplicate values, okay? So if you have a linked list like this, like 1, 1, 1, and if you are going to check if there's a cycle or not, these two ones doesn't actually mean there's a cycle. That's just node's value. So you need to check the class reference of it, okay? The simple common values are not the same nodes. They want you to check for it. In here, this linked list actually will go like this: 1, 2, 3, 4, and 5. And after 5, we have a cycle here, and it will point to the second node again, and it will go like this: 2, 3, 4, 5, 2, 3, 4, 5. Actually, if you want, you can try it like this. Just print the linked list. It will give you infinite output. Let's try to check it now. As you can see, it doesn't finish, and if you look here, 2, 3, 4, 5, 2, 3, 4, 5, it has a cycle, and we need to check if there's a cycle or not. Let's first solve the solution with the double pointer technique in the 8th video, which you are familiar with now. So actually it will go like this. We can call this boolean because it's just returns a value true or false. Let's call our function has cycle. It will just have one parameter, and it's the head node. And now we need to create our two slow and fast nodes here. Fast will be equals to head, and slow will be equals to head. I've written it one line here. If you don't know how this one line referencing works, if you are creating pointers, guys, you need to put a star reference here to say that it's a pointer again. If you try to initiate it like this, you'll get an error, okay? So if you remember from our 8th video, we need to create a while loop here. And in our while loop, we have two conditions: while our fast is not equal to null pointer, and our fast's next is not equal to null pointer. If you forget to write the first operation here, where the fast is not equal to null pointer, if your fast is null pointer, guys, since there is no fast's next because it's a null value, you'll get a runtime error. Therefore, check always is fast is equal to null pointer or not, okay? And if you want, you can use just null here. It's your choice. So if you remember from our previous lecture, we need to update our slow and fast nodes here. Slow will be equals to slow to next, and fast will be equals to fast to next to next. So why does this work? If our linked list contains a cycle, and we are traversing the slow node just 1, and if we are traversing our fast node with 2, so simple math here actually. So fast is going twice the speed of slow. Therefore, these two will intersect at some time in our linked list. But the problem with this is if your linked list is huge. For example, we just have 5 nodes, but if it holds 1 million nodes, and if you're going to check if there's a cycle or not, and for example, if the cycle starts at 900,000, and if your 900,000 points to the like 3rd or 4th node, this will intersect so late in time, which will give some performance issues. But let's do it now. Now we need to check if our slow node is equal to fast or not. So nice and simple. If our slow node is equal to our fast node, we'll just return true here, and otherwise we'll just return false here. Be sure to write this if condition after you traverse the nodes, because if you write it at the start of our while loop, it will always give 1, because in our initial condition both of them are equal to head. Okay, so remember it. Let's try it now. So now I'm going to comment this because it's an infinite loop. And now I'm calling our function and put a new line here. As you can see, we have successfully get 1 here. Now let's retire cycle from our linked list. So fifth to next, we can initiate this to null pointer. Now we have no cycle, it's just a simple linked list of 5 nodes. And let's run it again now. As you can see, we've got 0 here. So what about the next technique? Actually, the next technique is really easy. You can just use an unordered set, guys. An unordered set, if you don't know, is an hash set actually, with all keys equals to some hash function. And you can put only one variable once. Therefore, it will just hold the unique values, and we are going to check if our unordered set contains the current node. If it does contain it, we know that there's a cycle and we'll return false from there. So let's write it now. Let's call this bool has cycle. Let's call it set for simplicity. It will have our head node again, and let's create our unordered set here. Unordered set of likeness node pointer. Don't forget the star there. Let's call this uset. And now let's add our head node here. Okay. Actually, we don't need to insert it here. Let's create our while loop now. So while our head is not equals to null pointer. And now we need to check if our linked list contains the current node or not. It will be really simple. You can just use uset.count method. This count method returns 0 or 1 depending if your unordered set equals to unordered set contains the head node or not. So if our unordered set contains our head node, we'll just return true from here since it contains a cycle. And if it does not, we are just going to insert our head node to our unordered set here. And now we need to traverse our head node. So head will be equal to head to next. And if somehow we have successfully exited from this while loop, and since we've checked if it counts the same node twice, this will hit and we'll return true. If not, we know that it doesn't contain any cycle, so we'll return false from here. But remember, if you are using unordered set, you don't need to implement any complementary function, any comparison function. But if you want to use the normal set, you need to implement a comparison function by yourself. Just remember it. Now let's check it again. So I am calling has cycle set here again and print a new line here. As you can see, we've successfully checked if there's a cycle or not, and it gave us the value of 1. And let's create a simple linked list now without any cycles. As you can see, we've successfully get 0 from there. So let's talk about the efficiency of both of these functions. Actually, both of them are really good. However, if you encounter this problem on some website, I don't know, some challenging websites, and if you get time limit exceeded with this method, guys, just be sure to try this one. So the price difference here is this can sometimes work slower than this because it just traverses nodes by 1 or 2, and we are waiting for them to intersect at some point. But in here, we are just using extra memory. We are not using any extra memory here. So let's try that actually. O1 memory. But in here, we can actually get a maximum of order of n-1 memory, but this can be more efficient and time complex. Both of them are fine. Choose whichever you want to write. I think this one is a little bit easy to understand and a little bit easy to write, but it's just your choice. And if you're worrying about how to write this one in a set, you are just going to write a simple function like this, like bool compare, and this will hold two linked lists, like L1 and linked list node pointer L2. You can comparison by their data actually. So you are just going to return L1.data smaller than L2.data. You can implement a complementary function like this. Actually, this is it, guys. So see you in the next tutorial. Take care. If you have any questions about linked lists, just write it down in comments and I'll try to answer them. So see you guys in the next video.